Okay, good evening to my lecturer, Dr. Hafizuddin. My name is Parthiban Anaki Ganesh from RY44. My entry number is 191382582. Okay, I'm here to demonstrate and explain about the lab that Dr. give. That is lab 1 operation amplifier with inverting and non-inverting amplifier. Alright, now the objective of the experiment is to demonstrate the inverting and non-inverting and investigate the operational amplifier voltage follower. Alright, now firstly I'm going to do the inverting amplifier. Okay, before that, these are the components that we have to use. So we have to exclude the breadboard and oscilloscope because we are going to build this circuit in multisim. Alright, now before this is the inverting amplifier. So before that I want to show the calculation for inverting amplifier, because before we do experiment we must calculate. So with that calculation we must do the experiment and then we must compare the value, either it is same or slightly same, or it have increased or decreased. Okay, let me show you the inverting. Okay, for inverting, this is the formula for inverting: 1 plus RF divided by R1. Okay, as we can see, 1 plus 4.7. 4.7, because we are using three resistors: 4.7, 33 and 10. So firstly we start with 4.7. Okay, as you can see, 1 plus 4.7 divided by 1, we get 5.7. Then for V out, AV, we times it with V in. So AB already get 5.7, so times it 1. Okay, the V out is 5.7 volt. So this is our calculated for 4.7. Then we go for 10k. Okay, for the 10k, same as follows: AV equals to 1 plus RF or R1. V out also AV times V in. When we get AV, then we can find out our V out. So both is 11 and 11 volt. Okay, for calculation for 10k, we only get. So then we go for 33k. For 33k, same as all for the before this previous formula: 1 plus RF over R1, then for V out, AV times V in. So both are same, 34 and 34 volt. Okay, now we must do the experiment. Okay, now for the experiment, okay, this is non-inverting. Okay, for non-inverting, this is a circuit. This is a circuit I built. So when we run, okay, now we can see with the calculated and with the experiment value. This is the calculated, that is AV. Okay, before that I want to tell about this green, purple, blue and light blue. Okay, the green is represent maximum value. The light blue down here is minimum value. As for the purple here represent output, and this blue is input value. So we can see the peak here and then the peak here for the experiment value for 4.7. Okay, now we must change this. Okay, 4.7, right? So now we're going to do for 10. Okay, now we do for 10. Now we run. Okay, you can see the graph, right? Okay, for the graph, same as maximum and minimum value. As you can see the peak, right? This is the peak. It's all based on calculation. Either it's same or not. But as we can see, the based on the calculation and the experiment, the value will not be accurately same. Some will be a bit decrease, a bit increase. So This is the value for 10k. Now we change 10k to 33k. Okay, we run. Okay, for this you can see it's the peak 13. Then this is the peak for V out. Okay, this is I already done for the three resistors 4.7, 10, and 33k. Okay, now we go for calculation for non-inverting. Okay, non-inverting. Okay, this is non-inverting calculation, because before calculation we must, before experiment we must do the calculation. So okay, for the AV is equals to negative RF divided by R1. So as we can see the formula negative 4, we start with 4.7. That's with resistor 4.7. Negative 4.7 divided by 1, so it's negative 4.7. Then for V out equals to AV times with V in. So negative 4.7 we only get AV, so times with negative 1, the value is 4.7. It's same, AV and V out same, just that AV we have negative, V out we have positive value. Now for 10k same as the previous formula, AV equals to negative 10 over 1, V out equals to AV times V in. Okay, as you can see, AV we have negative 10, V out we have 10 volt. Alright, that's for 10k. Now for 33k is same as previous one, AV equals to negative 33 divided by 1, negative 33, and for V out, AV times V in, we got 33 volt, negative and positive. Okay, now as for experiment we did in multisim for non-inverting, so we start with 4.7. Okay, for 4.7, as you can see, like before this is the maximum minimum value, and the purple is output value and the blue is input value. You can see it is not as same as the calculated value, so it will be slightly decrease and slightly increase. Okay, this is for 4.7. Okay, now we change it for 10k. Okay, for 10k, now we run it. Okay, same, this is the value for AV, it's V out. Now you go for 33. Okay, okay, this is for 33k as follows. This is the value for the experiment value. Okay, now we have done the non-inverting and inverting. Okay, now we go for the left sheet. Okay, okay, from the, now I'm going to answer the question, right? Okay, why are the output of the waveform have been clipped? Okay, why the waveform have been clipped? It's because V in and V in times V gain is V in and V gain is how to say, increases with V source, voltage source. Okay, and why it is called as inverting amplifier? Okay, we put for example we can say that inverting, it changes from negative to positive, so we put negative, then we get negative type. type of wave. So as we can see, the output is like positive wave. So we can see that it is inverting amplifier because it changes from negative to positive. All right, this is for I answer the question for inverting amplifier. Now for non-inverting, okay, why it is called non-inverting amplifier? It is called non-inverting amplifier because it produces only amplified or amplified output signal. Okay, as we can see, this output signal is non-inverting, is in phase with applied input signal. So it becomes non-inverting because wave will not change its phase when amplifier is in controlled motion. Okay. Now okay. Now why is it called as non-inverting amplifier? I am answering this question for non-inverting amplifier. It's called because it produces only amplified input signal, and this output signal of non-inverting is in phase with applied input signal. Okay, what does non-inverting mean if a sine wave is connected to an operational amplifier positive terminal? So it means that it will become non-inverting because the the wave will not change its phase and the amplifier is in controlled motion. Okay, what can I discuss from the question that I answered from the non-inverting and inverting is that from this both circuit, the output and the input is quite same value as we calculate. Not to say it's quite same, but it is slightly same because we cannot get the accurate value from the experiment and the calculated value. So I think it's proven. The experiment is proven. Then okay, as for the conclusion, for this lab one, we have got the output for inverting and non-inverting. So from this I can conclude that I've known the function of the inverting and non-inverting amplifier very well by using multisim, and I have known how to use multisim with a proper way in online. All right. Okay. uh, Thank you, sir.